Section 21 Ground Investigation Boreholes. Borehole drilling methods. Holes may be drilled with a great variety of commercially available rigs. Methods fall mainly into three groups, dictated by the need for soil or rock penetration and a required sample or core recovery. Light percussion drilling. Mobile A-frame, easily erected with power winch. Steel shell is driven into ground by weight repeatedly dropped 1 to 2 meters and lifted by cable over A-frame, hence cable and a tool rig. Only for shallow exploration of soils and soft clay rocks. In clays, smooth shell is driven by weight dropped onto it and soil adheres inside. In sand, whole weighted shell may be arched and dropped, and soil is held inside by hinged clacked valve. Can aid light rotary drive for auger drill in clays, hence shell and auger rig, but less suitable for most site investigations as the sample is disturbed. May use chisel head for limited rock penetration, widely used as all sites need soil investigation, usually with 100 mm sampler inside 150 mm casing, reaching depth of 15 to 40 meters. Trial pits and trenches. Cheapest method of shallow soil exploration. Dug with any side excavator with backhoe. Usually 2 to 5 meters deep, may need temporary support or safety cage to allow full inspection of exposed wells. Especially useful in variable man-made fields. Valuable in disturbed or slipped material, including soliflected head, as shear surfaces may be recognized in clean cut walls and not in borehole cores. Can cut block samples or drive in under 100 sample tubes with backhoe, or test load a plate on pit floor. Trenches can expose rock head in search for fractures or outcrops. Avoid trenches precisely on foundation sites. Backfill with compacted soil or lean concrete. Pits and boreholes may need sealing to prevent groundwater movement through breached aquiclude. Rotary coring. Truck-mounted rig with full rotary drive, which can be applied with downward force. Air, water, or bentonite mud flush pumped down inside drill string and washes chippings back up outside. Tip of cylindrical drill bit is tungsten carbide or with diamond inserts, hence diamond drilling. Normally, double tube barrel holds full core in inner non-rotary barrel about 1 to 3 meters long. Can penetrate any soil or rock to greater than 100 meters deep. Commonly use N size, providing 54 mm diameter core from cased hole of 89 mm diameter. Larger diameter is better in weaker rocks. Continuous flight hollow stem auger can be used in clays, not common in exploration. Borehole records. All boreholes must be logged as completely as possible to be cost effective. Best to use conventional samples for ease of reading. Log must record at least the data on this example. On some style of conventional prepared booking sheet, though there is no single all-purpose format. Description, thickness, depth, and the scale pictorial log provide a basic understanding. In situ tests quantify ground properties. Standard penetration test is easiest borehole strength test for soils. N value increases with strength. We will further discuss this in section 26. Or use count penetration test. This also we will discuss in section 26. Point load strength is field test on borehole core of rock. This we will discuss in section 24. Rock quality designation is measure of fracture density in rock, and we will discuss this further in section 25. And a core recovery is measure of weak broken zones. Both values increase with quality and integrity of rock mass. What table and inflow points should be recorded, and a permeability may be determined by Piker tests, and we will discuss in section 18. Sample points are noted. In this slide you can see on the left side there we have given a sample of logging format. On the right side, how many boreholes, how deep. To investigate an area, how many boreholes you need to drill and how deep. Spacing. For buildings, 10 to 30 meter apart. Road lines, 30 to 300 meter apart. Landslides, at least 5 in line for profile. Depth, 1.5 by foundation width, below founding depth, plus at least one deeper control hole to 10 meter below foundation, unless rockhead found. 3 meter below rockhead to prove sound rock. Probes to 3 to 10 meter to look at rock cavities. These are only rough guidelines. Spacing and depth may be varied considerably in light of local conditions and appropriate to size of structure. Cavernous rock may need probes at each column base. Old mine working may need proving to depths of 30 meter, and a location of old shafts may need probes on 1 meter grade. Borehole costs. Drilling costs are best estimated as accumulation of number 1, cost to supply rig onto site, cost of setup on each new hole, cost per meter of hole drilled. Table shows approximate relative cost according to 2001 figures in this one. On-site plus per hole plus per meter. Light percussion, soil less than 10 meter deep. On-site 300 per hole 30 and per meter 14. Probing in rock or soil 350 40 12. Trial pits 4 meter deep backfilled 250 or 4 pits. Costs vary with number of in situ tests required. Probes are cheaper on close-spaced grill and in uniform rocks, which do not require a casing of hole.